So I'm going to record the solutions to your sample test. Here's the first problem. How do we integrate this one? So this is when you need to recognize that this function has a discontinuity at x equal to 3. So this is what we call improper integral. Solution. Replace the 3 here with t. This is the integrand. And then let t goes to 3 from the smaller side. So I have to evaluate this definite integral first. Let's try to do the indefinite integral. Sorry, this is 3 minus x to the power of negative 1/2. Okay. And to integrate this, we let u to be 3 minus x du negative dx. That's u to the negative 1/2, and dx becomes negative du. So I put a negative sign outside. Sorry, that's the indefinite integral. Simplify this. This is positive 1/2. Make it positive 2 in the front, negative 2 in the front. U to the power of positive 1/2. So now we should be able to evaluate this definite integral here. Equal to limit t goes to 3. I'm going to plug in 2 and t in this one, okay? First, I plug in t, and then plugging in 2. So it's minus minus become plus. And want to find out what is the limit of this. This is obviously just 1 back here. This one, when t goes to 3, 3 minus t goes to 0. This goes to 0, and because the power here is positive, and 0 to the power 1/2 will be 0. That's why we say the answer is 2. Okay, the answer is 2. Okay, so that's the first problem. The second problem appears there is some problem. You won't be able to solve the integral here. Here's the arc length formula. Alright, so for the example that I presented, that I showed on the sample test, is actually not working, okay? When you when you write down f prime, you get something like this. Plus 1/2, there's a coefficient in the front, and then try to differentiate x to the power of negative 2, where you bring the negative 2 in the front, and then do x to the power of negative 3. Okay. This one, I do not believe that you can actually FOIL this out and then complete the square and then get rid of the square root. And that's why this example is not working. So let me replace this problem with a different one, where f of x is given by this formula. which is very similar, but let's try this out instead, okay? Let's differentiate this guy first. That's 1/4 -2 x to the power of -3. Minus, that's actually minus 1/2 x to the power of -3. So arc length, let's still look for the arc length between 1 and 2. So we're going to square this one out. Square this out. The last one is plus x to the -6 over 4. Alright, so the number in the middle turns out to be minus 2 times by this one and then this one, which turns out to be -1/2, okay, -1/2. And this is also what we practice in class, that this gives you a perfect square, which is exactly this one, but now absorbing this one here give you a positive 1/2. See that? So this one minus 1/2 is positive 1/2, which allows you to complete a square. All right, this one is the perfect square for this term. X cubed over 2. So now the square root is cancelled with this power function here, and you should have no problem integrating this out, okay? And I leave this to you guys. Surface area. Surface area, if you are rotating about, so here you are rotating this curve about the x-axis, find out the surface area between 4 and 9. F of x rotate about the x-axis. The surface area formula look like this: 2 pi f of x square root of 1 plus f prime square. Okay. So now my f of x here is square root of x. Just plug that in. One plus the derivative squared. Okay. So this is x to the power of 1/2. You're gonna differentiate it. No, its derivative is 1/2 -1/2. So write that down here, okay? 1/2 x to the power of -1/2. So your task is try to integrate this one out. That's 1/4. That's x to the -1. So this one seems like tricky to evaluate, but we're going to multiply those two square root together. So I have to think about how to integrate this. Big square root. X times by 1, just x. X times by x to the power of -1, that's just 1. So it's just 1, alright? So that's what we're left with. which is kind of easy to integrate, okay? Normally, you're going to have to do a quick substitution rule here, but this one's extremely easy. And the answer is this radical to the power of 1/2 plus 1. Alright, and then you plug in for 9. That's how you integrate this power function here, okay? So that's that. The fourth problem is sketch the curve given by this set of parametric equations. This is relatively straightforward, okay? So to plot the curve, I just to plug in a few typical t values, and then carefully calculate x and y. Alright. We're going to try a few numbers. 0, for example. Pi over 6, for example. And maybe pi over 3. How about pi over 2? And I can also try 3 pi over 4. And finally I'll try pi. So you carefully plug in those angles. Here's what I found. Here's what I found. Pi over 6. So you can estimate this. This is slightly smaller than 3. It's like 2.7 something. Pi over 3. And then 1 plus 2 times by 1/2. Cosine pi over 3 is 1/2. So that makes this one 2, okay? Pi over 2, 1. So did you notice the y value keeps dropping? 3, 2.7, 2, and 1. 3/4. 1 minus 2 times the square root 2 over 2. So that's actually 1 minus square root of 2, okay, which is around 0.4, negative 0.4. Pi, sine pi is 0, that makes this guy negative 2. Cosine pi is negative 1, that makes this guy negative 1. So the y value keeps dropping, going all the way from 3 to negative 1. And then you try to carefully plot all the points, and here's how it roughly looks. Negative 2, negative 2, 3. This is negative 2.5. X is negative 2.5. Y is 2.7, so it's around here. That's that point. Negative 2 minus square root of 3 over 2, and the y value is 2. You can plot that point. That point is actually around here, okay? So you can take out your calculator and get an estimate on this. Pi over 2 is negative 3, 1. Okay, so here is negative 3, here is 1. Negative 3, wait, negative 3, 1. Sorry, negative 3, 1. 3 pi over 4, which actually makes it a little bit down here. And then negative 2, negative 1. X, negative 2, y is negative 1. Making this point. So my plot is not very accurate, but if you're carefully plot all the points, you will actually see an ellipse, okay? Half of an ellipse that going downward like that. The full ellipse will look like this, but this is just half of it. That's just half of it. So all I'm asking you just you know how to plug in points and plot some points. Part B, it is asking to get rid of the parameter here. All right, it's getting rid of t here and come up with the Cartesian equation. So here's what I will do. From the first equation, I solve for sine t. Turns out to be -2 minus x. And solve for cosine t. Y minus 1 divided by 2. So now we're going to use the identity that sine t squared plus cosine t squared is 1. Just plug that in. Here's what I end up with. Okay? And that's the Cartesian equation what I'm looking for. I can rewrite this a little bit more, and I get x plus 2 squared, y minus 1 squared over 2 squared. You don't have to do this, but this clearly indicates this is the ellipse. The center is -2, 1. Okay, the center is -2, 1. So that's the center of the ellipse with some major axis and minor axis. So you can review about the ellipse. Okay, so that's number 4. Number 5. So here we have another set of parametric equations. We're looking for the point where the tangent line is horizontal or vertical. So first I need to calculate dy dx. dy dx, which is dy dt over dx dt. dy dt is 2t and dx dt is 3t squared minus 3. Which you can factor out. Take a 3 out, for example, t squared minus 1. So now we can use the identical where the tangent line is horizontal. That is when the numerator is 0. In other words, t is 0. The tangent line is horizontal. Okay, because the slope will be 0. And I can actually find out the actual point. The actual point has an x value. When t is 0, x value will be 0. When t is 0, the y value is -3. So that's the actual point on the curve. Part B is looking for where the curve is concave up and it's actually asking for where the if the curve is concave up or concave down when t is between -1 and 1. So here's what I will do. I have to calculate second derivative, which, if you recall, you're going to differentiate, take the derivative of first order derivative that you already calculated up here, and dx dt on the denominator. So you're supposed to differentiate this one with the quotient rule. I'm going to do it right down here. 3, that's a 9, t squared minus 1 squared. 2 minus 2t times by the derivative of the denominator, which is 6t. Alright. Divided by dx dt. dx dt again is 3 times by t squared minus 1. Put those terms together, that's a 9 and 3, which is a 12 cubed. The numerator, we'll simplify this. That's 6t squared minus 12t squared, so it's negative 6t squared minus 6. The question was asking, is this guy concave up or concave down between negative 1 and 1? Alright? So what I will do here is I will pick a test point to check the sign for this guy on this interval. So t is 0. The second order derivative will be plug in 0 here, okay? The top is obviously always negative. The denominator is going to be negative as well when t is 0. So that makes this guy positive. Thus, the conclusion is it is concave up, okay? The curve is concave up. Concave up. If you're actually asking to find out where this guy's concave up, concave down, you have to look for the points that make the numerator equal to 0, make the denominator equal to 0, which, if you recall, cut the t-axis into several parts, and then you pick the test points on those intervals and check the sign for second derivative. That's how it's done. So I can't exactly slow things down and do some chat along the way. I will have to just dive directly to the problems. Now we're going to work on number 6. Number 6. The sequence that I have is given by this formula. The first part is this one increasing or decreasing, or actually show the sequence increasing. If I actually want to find out what happened to the sequence, I will plug in different ends and check out if it's getting bigger or smaller, okay? But to show it's increasing means I need to show a sub n is less than a sub n plus 1. So the next term is getting bigger. A n plus 1 is, so you replace n with n plus 1. Replace n with n plus 1. Simplify. Sorry, this is plus here. Okay, and then we do the cross multiply. FOIL things out. This is not minus, sorry, it's plus, right? Negative 2n plus 3n. And squared and plus n minus 2. Identical terms. So this is equivalent to say negative 6 less than negative 2, which is trivial, okay? So that's how it shows it's increasing. B. Is the sequence bounded from above? If so, give a number that is bounded above by. So like I said, the sequence itself is this one. You can plug in a few numbers to see what happened. For example, equal to 1, a equal to 2, a equal to 3, a equal to 4. Alright? Many of you can say, yes, it is bounded from above. Give a number that is bounded above by. So I can say, hey, because n minus 1 over n plus 2 is obviously always less than 1. That's why this guy is bounded above. Right, so that's going to be one number. Use 2 if you want to, that also work, but 1/2 is not going to work, okay? For those who are wondering, why this is less than 1, you can easily tell this is identical to n minus 2 less than plus 2. Just multiply n plus 2 on both sides, which is trivial, okay? So that is number part B, okay? That's part B. Part C, it is asking for the associate sequence. Sorry, not associate sequence, associate series. C Is the sequence convergent? You're going to say yes. The reason is because it's bounded from above and increasing, right? Increasing. Thus convergent by the theorem we talked about, which is called monotone convergence theory. If it's bounded from above and increasing, it'll be convergent. So you got a sequence that keeps getting bigger and bigger, but at the same time is capped off somewhere, bounded from above, then it has to be convergent. Okay, this is so-called monoconvergent theorem. D is actually to find the limit is easy. Okay, here to find out the limit as it goes to infinity. Divide the top by n, divide the bottom by n, and this one goes to 0, this one goes to 0, so the answer is 1. Okay, it's 1. D is the corresponding series convergent or divergent? Explain why. Since the term in the sequence in the series, so that's the term in the series. Okay, this guy goes to 1, which is not 0. Thus, this infinite series diverges. Thus, it diverges by test of divergence. Test of divergence says as long as the term does not go to 0, the series must be convergent. It didn't say anything about what happened when the term goes to 0. Okay, it only says if this guy does not go to 0, then the infinite series must be divergent. Number 7. We're talking about this series here. Find the sum if it converges, otherwise give reason why it diverges. That's what the series we have. If you look at this together, it's not going to work. It's very hard to find this out. Instead, you want to separate this into 2 different series. Alright, minus. You can take the 2 out if you want. There's a 2 here. And then write this apart if you want, okay? You plug in a equal to 1. You get 1, a equal to 2, a equal to 3. 3 minus 1 is 2. So you look at a series like this, in other words, a geometric series. So the answer to this will be, remember the formula for geometric series, the sum is a over 1 minus r. That is when r absolute value is less than 1. Okay, this works when r absolute value is less than 1. So that's why the answer to this is 1 over 1 minus 1 half. Same story for this guy. Write it apart if you want to, but the first term is 1. The ratio r is 1/3. So that's why the answer is negative 1. Alright. And now we are on to the last problem. The last problem is about direct comparison test. Direct comparison test. So I have to compare this guy with something. So obviously you need to review the direct comparison test, okay? Direct comparison test. that we covered on Friday. Direct comparison test. So solution. So we want to come up with something to compare with. But without coming up with anything to compare with, when you look at this guy, this is similar to 5 over 2 to the n, which is the p-series that we talked about. Okay, p-series that we talked about. So you're going to say since we're going to compare this guy with 5 over 2n squared. This denominator is bigger than this one. This one is bigger than this one. That's why the whole fraction is less than this. So this is smaller than this. Because it's less than this, and this one, this is the b sub n that we have. Okay, this is the b sub n. And this one converges because it's a p series. Okay, it's a p series with p equal to 2. Okay, it's a p series with p equal to 2. The larger one converges. This is a result that you want to memorize. Okay, p series always converges whenever p is greater than 1. If this power here is bigger than 1. Thus, direct comparison test says the larger one converges, smaller one must be convergent.